Hello everyone. I am opening the second online meeting now. Welcome to our presentation. We are from Turkey. We will start first. Our presentation will be given to students. It is their turn. Hope you like it. Yes, İrem.
Hello everyone, my name is İrem, also my friend's name is İrem, and our teacher's name is Pınar. We provide contributions from Ankara, Turkey. Welcome to our presentation. We are excited and a little bit nervous about the presentation that we will do this for the first time. We hope we'll do a good job. Before we start, I want to say that thank you for giving us the chance to include us in this project. We are so proud and happy. Now let's move on to the presentation about the encryption we created. İrem.
Firstly, we wanted to show the beautiful places of Ankara. You are looking at it right now. The first picture belongs to Anıtkabir. Next to it is Ankara Castle. There are also pictures of Hacı Bayram Mosque, Kocatepe Mosque, and Hamamönü, etc. Without further delay, let's talk about the encryption we created. The Wegener square or Wegener table, also known as the tabula recta, can be used for encryption and decryption. Next page. Now I will explain to you the Wegener encryption method. The Wegener cipher is a method of encrypting an alphabetic text by using a series of interwoven Caesar ciphers based on the letters of a keyword. It employs a form of polyalphabetic substitution. In a Caesar cipher, each letter of the alphabet is shifted along some number of places. For example, in a Caesar cipher of shift 3, A would become D, B would become E, Y would become B, and so on. The Wegener cipher has several Caesar ciphers in sequence with different shift values. To encrypt a table of alphabets can be used, termed a tabula recta. It has the alphabet written out 26 times in different rows. Each alphabet shifts cyclically to the left compared to the previous alphabet, corresponding to the 26 possible Caesar ciphers. At different points in the encryption process, the cipher uses a different alphabet from one of the rows. The alphabet used at each point depends on a repeating keyword.
For example, suppose that the plain text is to be encrypted is a take it down. The person sending the message chooses a keyword and repeats it until it matches the length of the plain text. For example, the keyword lemon. Each row starts with a key letter. The rest of the rows hold the letter A to Z in shift order. Although there are 26 sorry, I'm so excited, I'm confused. There are 26k rows shown. A code will use only as many keys at different alphabets, as there are unit letters in the key string. Here does 5 keys: L, E, M, O, N. 4 letters of the key message. Letters of the message, successive letters of the key string will be taken and each message letter enciphered by using the corresponding key row. The next letter of the key is chosen and their row is gone along to find the column heading that matches the message character. The letter at the intersection of key row, MSG code, is the enciphered letter. The first letter of the plain text, A, is paired with L, the first letter of the key. Therefore, row L and column A of the beginner's square are used, namely L. Similarly, for the second letter of the plain text, the second letter of the key is used. The letter at the row E and column T is X. The rest of the plain text is enciphered in a similar fashion. The encryption is performed by going to the row in the table corresponding to the key, finding the position of the ciphertext letter in their row, and then using the columns labeled as the which plain text. For example, in row L from lemon, the ciphertext L appears in column A, which is the first plain text letter. Next, in row E from lemon, the ciphertext X is located in column T. Thus, T is the second plain text letter. Next page.
Okay.
Here is the table we created with emojis. You can see that the columns and rows are arranged alphabetically, just like in the beginner table. And if you want to encrypt it easily, you can write the alphabet instead of emojis. Next page. We have also written an example for you here. We'll wait a moment for you to review. You can examine it for yourself. And if you did examine it, we can go to the next page.
Shortly, we were inspired by beginner cipher while creating our encryption. It's the same method, but we created it with emojis. We thought it might be fun, and we think this happened. Each emoji corresponds to a letter. The receiver and sender know which letter the emoji means. So we can create and decrypt passwords using the table. And we have project members on this page. Last page and presentation is over. Thank you for listening. If you have any questions, please feel free to ask.
Thank you very much. It was very interesting, and I think the code is not so easy, but I don't know that so many smileys exist. It's nice. Thank you.
Thank you.
For listening. I hope enjoy this presentation.
I smiled all the time.
Thank
It
you.
was nice. Thank you.
Now I am inviting Slovakia for their presentation.